Okay, in this video, I'm going to demonstrate how you can carry out confirmatory factor analysis using the Lavaan package in R. There are several different ways of doing this, but I'm just going to mainly show you how to carry it out using the CFA function. I'm also going to show you how you can obtain path diagrams as well using the semPlots package. So first off, I've got this notepad that's opened up, and I'm going to include this underneath the video description. So because I'm not going to be able to cover everything that is in this particular notepad, but I've got a lot of the syntax and instructions in here, so you can download it underneath the video description and follow along. But in this notepad, I start off with just kind of noting where you can find information on the Lavaan package, and also the semPlot package. So you can see right here, this is where you can get the PDF of the package information. There's a great article right here that you can go to and download it and follow along. And then there's also a nice little tutorial right here. In terms of semPlot, you can get information on the package right here. So also for the demonstrations in this particular video, I'm using the Halsinger-Swineford 1939 data. Now, the Lavaan package actually incorporates that, so you don't actually have to download or install this data set. But in the interest of basically for those folks that maybe don't have much experience with importing, reading data in from different files into R, I thought I would just create a CSV file with the data set. And you can download a copy of it right here, and I'll just show you really briefly how to read it in. But this is the data set from that, and then I also have a second copy of the data set right here that contains missing data. So you will need to install Lavaan and semPlot in order to follow along with the tutorial. So I'm using the install packages function right here, and inside the parentheses and inside the quotation marks I have Lavaan. And notice it's all in lowercase letters. So make sure that you don't add anything or subtract anything from what you're seeing right there. And the same goes for semPlot. In this case, we have a capital P. So make sure that you follow along exactly. So install these two packages. And once you've installed them, you're going to need to call them up using the library function. And so you'll see that we have library and then Lavaan and then library and then semPlot. So just note that if the packages are not activated and brought into memory, then if you start trying to use the functions associated with them, then you're going to get error messages. So the first thing I'm going to do is go back to R right here and note that, again, just in the interest of helping those folks that have less experience with reading data in, I've already downloaded those two CSV files to my downloads folder. So the first thing that you need to know is that when you're working with R, you need to point R to the folder on your computer or on your drive that contains your data. So if you don't do that, then it's not going to be able to find it. So the first thing I'm going to do is I'm going to click on File, Change Directory right here, and it's under my Downloads folder. So I'm going to click on that, click on OK. And so now my working directory is essentially my Downloads folder. So at this point, the next thing I'm going to do is go ahead and read in the data. So and what I'm going to do in this particular video, I'm going to do a lot of copying and pasting out of this file. And I do want to point out that a good strategy, particularly when you're working with more complicated models, is to just open up a notepad and then type in the syntax, the R syntax, and then paste it back into R. It can be really handy because when you're typing things in directly, it's very easy to make mistakes and so forth, and you end up with a lot of error messages and so forth. So it's just easier to kind of create a notepad and then type the syntax in and then copy it and then paste it in. So I'm going to copy this and paste it in. You'll see that the syntax, I'm creating a data object called Halsinger-Swineford 1939. I'm using the read table function in order to call up the data set that is in my downloads folder, which is Halsinger-Swineford 1939.csv. You'll see that if header equals true, again in all caps, and then SEP equals, and then I've got a comma, so it's just indicating that we're working with a comma separated file. So at any rate, what we'll do is we'll paste that in to R and hit it, and so now we're all ready to go. So if you want to take a quick look at the data, we'll just type in Housing or Swineford 1939, and there it is. So you can see this is data from a group of school kids on various mental abilities, and so you'll notice that basically we have X1 through X4. Those are measures of various mental abilities, and X6 through X9 are others. And we'll just take a look at the data set in general. What I'll do is I'm actually just going to copy this name because it's very easy, again, to make mistakes. And so I'll just use the str function to look at the structure of the data, and there it is. So you can see that we have variables X1 all the way to X9. So at this point, we are good to go for running some CFA models. So the first model I'm going to run is a basic one-factor model. And I'm going to fix, basically operate from the perspective of fixing the first factor loading to 1. So by default, when you're running the model, the first factor loading for or the first variable appearing in the list of variables associated with a factor is going to be fixed to 1 in Lavaan. So make sure that you keep that in mind. And the basic structure is this. I'm creating model 1. I'm creating a data object basically that contains the model itself. So the data object is going to be called model 1. I have an arrow pointed to it. So this is just a less than sign and then a hyphen. And then I have an apostrophe right here. So the apostrophe is denoting the start of the model information, and then you have an end apostrophe that denotes the end of the model. So you'll notice that I also have a pound sign right here, and following the pound sign in this line, this is all a comment. So anything following the pound sign is a comment. Then I move to the next line, and you'll see that I've got GME, and that's just basically the name of the latent factor that I'm using. So I'm just calling this basically general mental ability, or general, that sort of thing. So I'm just calling it GME for short. Following that, we have to indicate, note which variables are treated as indicators of GME. And so then I've got an equal sign and then a tilde sign. So it needs to be in that order. So equal sign and tilde sign is basically indicating that we have our factor GME, and it's being manifested by or indicated by these variables right here. And notice that there are plus signs separating them. So then following, again, we have our end apostrophe right here. So the next line starts with, I'm just calling it fit1. So I'm creating a data object that's going to contain the information from the analysis itself. So you can see right here we have a CFA. This is a function, CFA function associated with Lavaan. And then inside the parenthesis, we've got model 1. So this is the model information is being fed into the CFA function and analyzed. And so that's why we have model 1 right here. That's the first argument. And then the second argument is the data argument. So it's data equals, and then the name of the data object. So again, what we did up here was we created right here, we created a data frame that contains the information that we read in from our CSV file. So this is the name of our data frame that we're working from. So the next line, you'll see I have summary, and then inside the parenthesis I have fit1. So basically we're summarizing the model fitting that we did up here on this line. So fit1, and then I'm also asking for a variety of fit measures. So I just have fit.measures, and I'm setting that equal to true, again in all caps. And then we have parameter estimates with an E in caps. So make sure, again, that you pay attention to the cases for your letters. Inside that I have fit1, and then I have standardized. So right here, standardized equals true. This is going to allow me to get the standardized coefficients for the model. And then at the end, right here, I've got SEM paths. So you can see SEM and then capital P, and then the rest of it. And what this is going to do is give me my path diagram. So at any rate, just in the interest of time, what I'm going to do is just copy. I'll start off with this. I'm going to copy this and paste it into the program right here and hit enter. So if you were doing this directly, we would just type in model 1, my arrow right there, start with the apostrophe. There's my comma. I'm just going to say one factor model with loading fixed to 1. And then hit enter and then move to the next line and have GME and then equals and then tilde and then followed up with x1 plus x2 plus x3 plus x4 plus x5. You can see how tedious this can get and how easy it would be to make an error when doing this. So then follow that up with my end apostrophe right there, hit enter, and then we're ready to go. So the next line we're going to create is this one right here. So I'm just going to copy this and paste it in. So, and it's, basically we had a little bit of an error, and the reason why is because I did exactly the thing that I told you that you should have done, or failed to do the thing that I told you earlier that you should have done, which is to use the library functions in order to call up Lavaan. So you can see this is what happens if Lavaan does not recognize if you had called up the package. So what I'm going to do is type in library, because I have installed Lavaan and the SEM plots packages. So I'm going to type in library, and hopefully I can spell this, Lavaan. All right, so there we go. And I'm also going to type in library and then SEM and then capital P and this plot right there. And ignore the warning message. It's just telling you what Lavaan was built under. So now both of those have been completed. So basically, we still were able to create the basic model, but to run it using the CFA function, we had to actually call it up using or use the Lavaan package, but we had to call it up first. So let's do this again and do it the right way. So I'm actually just going to highlight this right here. It's the same thing as before. I'll call this up as well. So I'm going to copy this and paste it in here and hit enter. And there you go. So next, if we just type in summary and then fit1, which is the name of the data object that contains our CFA analysis, you can see right here, this is it. So you'll notice that we get right here, we get the chi-square goodness of fit test. You can see the estimator is maximum likelihood. There's our degrees of freedom and p-value right here. Under parameter estimates, you'll see that GME for the x1, that first variable, the factor loading was fixed at 1. To set the measurement scale for the GME factor. You'll notice that we have our, these are all unstandardized factor loadings and tests for the statistical significance of those loadings. And then we have the variances for all of the errors associated with each of the indicator variables. And then you can see that we have the variance for GME right here. So now, if I want a little bit more in terms of fit measures, I can type in summary. Again, I need fit1 and then fit dot measures equals true. So if I do this, if I type in summary, then fit1 and then fit dot measures equals true, then in this case I get the same information, the same coefficient estimates and everything and tests. But now you can see that I get a lot more. So I get up here, I still get my basic maximum likelihood estimate for the chi-square value and test and so forth. You can see that I get the CFI right here. There's the Tucker-Lewis index right here. You can see that we get, there's the RMSEA right here, the 90% confidence interval for the RMSEA, and the P test for a closed fit right here. We also get the standardized root mean square residual right here. So I'm not going to go into all that in terms of interpretation, just because that could take this video really, really long. But that's how you can get that information right there. If we ask for parameter estimates, and then ask and indicate standardized equals true, then I can get standardized coefficients. So in this case, what I'll do is I'll just type in capital E and the rest of estimates right there, fit 1, and then standardized equals true. And so now you can see that we get our standardized estimates for the model. So you can see right here, these are our original coefficients and so forth. You can see that we also get confidence intervals. And then our standardized coefficients that we typically are going to report on appear in the std.all column. So these are basically our standardized coefficients for the model. Now, the next thing, if we want to take a look at the model itself, we can use the semPlot package, and specifically we'll use the sem paths function. So you can see that the P in paths is in caps. So in this case right here, I'm just going to go ahead and copy this and paste it in the interest of time. So you can see right here that we have fit one, that's our object containing our results, what equals, and then quotation marks paths, comma, and then what labels equal, and then inside quotation marks PA. So we're basically asking for the parameter estimates to be included in the model. So we'll hit enter, and there you go. So there's our SEM paths in operation. So this is our one-factor model that we have just generated. If we want standardized estimates in the model, then we would, under what labels, we would say equals and then quotation marks stand. So if we want to take a quick look at that, I'll just copy it and let me get rid of this right here and paste it in. And so now we have our standardized estimates. So you can see up here that the variance for a variable is 1, and these are all the standardized factor loadings for a model. Now, let's say that we want to add in error covariances. So we can do that as well. So in this next model, we're going to run the same basic model, but then we're going to add in correlated errors. So I have basically, again, starting off with the apostrophe, then pound sign, just my comment right here. And then I've got, again, the same line as we had before. And then on the next line, I have a pound sign and then correlated errors. This is just basically a comment showing you where where I'm going. So Lavaan is not going to read that particular line. It's just in there for further edification. Then I have x2, and then I have a tilde, so two tildes followed by x4. So this is going to add in a correlated error between the indicators for x2 and x4. Then the next one, we have x3, and then we have two tildes, and then I've got x4 plus x5. So in this case, it's going to add in correlated errors between x3 and x4 and x3 and x5. And then you'll see I'm following it up with my apostrophe right here. I'm also going to use fit2. I'm creating a new data object called fit2 in order to analyze model2. So this is the basic model right here. So we're still using the CFA function. I've got model2. The data is exactly the same as it was before. So I'm just going to, basically all I've done is substitute fit2 into the remainder of these portions of the syntax. So in the interest of time, I'm just going to go ahead and copy all of this, and even that too. I'll copy that and I'll paste it in. And first off, you'll notice that we haven't created the diagram yet, so I can hit it right there, and there it is. And so you can see down here that you can see the correlated errors with the double-headed errors drawn between several of the different indicators. So we had that show up, and just kind of scrolling back up and just taking a quick look so we can run it as a batch. And so you can see that we have, there's our CFI right there, the Tucker-Lewis index. Basically all the same stuff that we were talking about before. There's your RMSEA and the remaining information related to RMSEA. And so there you go. So all that information we were able to quickly generate with that particular model. So once again, if we wanted the standardized coefficients, we could just, in our diagram, we could just kind of paste that in. You can see that now I've typed in stand instead of PAO. And so these are the standardized estimates. And so these down here, the correlated residuals, these would be correlations between the different, or excuse me, the different error terms. So next up, let's try a different model. In this particular case, let's say I want to, instead of having that first factor loading fixed to 1, let's say I wanted to just simply scale the latent variable by fixing the variance to 1. So in this particular case, it's essentially laid out exactly the same as what we had above. So all of this is exactly the same. I'm just still going to call this model 3, even though the syntax is exactly the same. Where things change is where it says fit 3. We're creating a new data object containing CFA results. So you can see I'm selecting model 3 right here. There's data. There's my data argument with the data frame noted. And then following the comma right here, I've got std.lv set equal to true. So in this case, this is saying standardize the latent variable. So and so when we do this, it's going to basically assign a variance to the GME variable of 1. So everything else I've just substituted, fit 3 in. So everything's exactly the same. So I'm just going to run this again as a batch. So I'm going to copy all of this and paste it in. And there you go. So now I've run this as a batch. And, basically, kind of going up here and just taking a quick look at the estimates, you can see that, we still have our various parameter estimates and so forth. You'll notice down here now it says variances, and it's got GME, and the variance is 1. And so there's no test associated with it or anything like that. So that is basically a few different models with the 1-factor model. Let's say we want to try a 3-factor model with correlated errors. So in this case, I'm creating model 4. Again, apostrophe, apostrophe right here. We have a comment line just saying what we're doing. And I've also created another pound and then a second line right here to carry things over. Now in this case, we're going to have 3 factors. So I've got visual and then equals and tilde. So visual is being manifest by indicators x1, x2, and x3. And all those are separated by plus signs. Then we have textual, and then we have equals and tilde, then x4, x5, and x6. Then we have speed. So these are 3 different proposed factors that may, that may explain the variation and covariation in the indicator variables. So then we have speed is being manifest by indicators x7 through x9. Then again, I've just added in the correlated errors comment right here. And then we have x2, 2 tildes, and then x4, then x3, 2 tildes, then x4 plus x5. And again, we have our n apostrophe. So then we have fit 4. So this is our 4th model that we're working with. So CFA is being performed on model 4 right here. And so let's take a quick look at it. So in this case, I'm going to highlight, copy it, and paste it in. And so now you can see that we have our 3-factor model. And you can see, basically, these paths right here are fixed to 1 because we're scaling the latent variables for each of these in reference to, the first variable that is in the list associated with those variables. So at any rate, there you go. That's the 3-factor solution right there. If we get all the same basic information that we had gotten before, you can see that up here under RMSEA, things are fitting a little bit better. We still have pretty low fit, but it's looking better. The RMSEA the SRMR is looking a little bit better as well. If we want to look at the comparative fit index, the CFI, you can see it's looking pretty good. Tucker-Lewis is marginal, I guess you could say. But overall, definitely looking better than the 1-factor model that we had tried previously. Again, if we want to look at the standardized coefficients in our diagram, we can just use the labels and then equals and then quotation mark stand. And so now basically we have our standardized estimates. So you can see right here, The double-headed arrows right here, these are just reflecting variances for the latent variables, and so all of them are fixed at 1, and then you've got essentially these coefficients are correlations, and then these are all the standardized loadings as well. So that is essentially that particular model. Now, let's say that we were having a problem with a situation where we had evidence of a lack of multivariate normality. So if normality is a problem, then what that can basically translate into, if we don't have multivariate normality, that can translate into basically biased test statistics and standard errors for the model. And so we can actually have an inflated chi-square values and also standard errors for the regression slopes and the various in this case our factor loadings and so forth that are too small. So it can actually lead to increased likelihood of type 1 errors at that level. So in this particular case, what we have right here, we still have model 5, and what I've done is basically we're sort of following along with model 4, but we're going to do that same model but then carry out our CFA using essentially a Satora-Bentler, requesting the Satora-Bentler chi-square and also robust standard errors. So everything in Model 5 right here, everything is exactly the same as what it was with Model 4, but now with Model 5, we're creating a new fit object called Fit 5 right here. CFA, we have Model 5. Everything is exactly the same, except now we have comma and then estimator equals, and then in quotation marks, capital M, capital L, and capital M. And so that's going to give us our robust test results. So now everything else is exactly the same. So what I'll do is I'm just going to go ahead and copy this as well and paste it in. Oops, let me get rid of this too. And so this is, again, we still have our diagram. But what I want you to kind of pay a little bit more attention to up here, you'll notice that now we have estimate here. We still have our standard maximum likelihood, but then over here we have our robust test statistics. So this is a robust chi-square value and our test results. You can see it says scaling correction factor for the Satora-Bentler correction. So that's it right here. As you scroll down, you'll also see that we have the we have the original CFI and TLI right here. Then we have robust versions right here. Underneath that column, and I guess some additional robust versions. Oops, excuse me. Some additional versions over here, so right there. So at any rate, just notice that we basically have robust versions of all these different test statistics and so forth. So that's great, and then the standard errors are adjusted as well for any kind of deviation from normality. So the next thing that I want to mention is, let's say we wanted to perform a second order factor analysis. So in this case right here, I'm going to do, we're going to create a model 6. So in this case, we're going to have, we have still our visual, our textual, and our speed factors. We're going to leave correlated errors in there as well. But in this case, I'm going to use GME as a superordinate factor, and the indicators of GME are not the individual items, but rather the factors that we had right up here, the visual, textual, and speed. So I've got GME, and then is manifest by, that's the equal and then the tilde sign, visual plus textual plus speed. So in this particular case, the analysis, I'm not going to do the robust estimation. We're just going to operate from the standard approach. So I'm going to copy all of this. And so there you go. So now you can see that we have GME up here. That's our superordinate factor, and then our 3 first order factors right there. So that's that's yet another model that you can run using Lavaan. Last, let me just kind of mention that if you happen to have missing data, then by default, what will happen is that listwise deletion will be used. If you don't want to use listwise deletion, one other approach is to use full information maximum likelihood estimation to account for the missing data. So I have this this Hall-Zenger-Swineford data set in a CSV format, but I've also kind of modified it to include missing data. So that's why it's called, it ends with a.md and then followed by the file extension right here. So I'm actually going to copy this and read it into R. So I'll do that. And if you just want to take a quick look at it, we'll just highlight, oh, excuse me. So the data object, by the way, is called HS missing. So I decided not to use the whole name. So the data object that contains the data from the CSV file is HS missing. So if I just type that in right here and hit enter, so just kind of showing you that this particular data set, you'll notice that there's some MAs in here, there's an MA right there, an MA right here, and so forth, and then right there, and some others. And so there's missing data. So if I run the CFA in the standard way, then what will happen is that listwise deletion would be utilized. So instead, what I'm going to do is I've specified a model, again, basically a three-factor model. And in this case, we're going to use full information maximum likelihood to estimate the model. So basically, this is very similar to one of the earlier models. So there's not really a whole lot of differences that are taking place here in terms of the actual syntax. But the fit7 data object, we're basically performing CFA on model 7. The data is called HS missing. So you can see right here the data frame is called HS.missing. And then I have following that a comma, and then missing, and then equals, and then in quotation marks FIML in quotes, and then there's my in parentheses. So when I do this, I'm going to highlight all of this, copy it, and paste it in right here, you'll see that basically this is what the end result will look like. So you can see right here that this is the path diagram. It looks like I included a comment in here as well. In fact, yes, I did. So there's no error or anything like that. I just included a comment just to highlight that the figure itself will look a little bit different from what we had before because means and intercepts were being estimated. So at any rate, scrolling back up and just taking a look at our results right here, you can see that we have the number of observations, missing patterns. There's 8 right there. So you can see that we're basically carrying out the analysis, accounting for the missing data. And so at any rate, pretty much interpretation of everything else proceeds in the same way that we've talked about thus far. So I'm not going to keep going with that. But that is basically an introduction to Lavaan using the CFA function in that package. And I hope that you found this video useful.